Hey team, so in section 5 we're going to start multiplying and dividing rational expressions. Oh yeah, lightsaber baby. Okay, so we're going to find products and quotients of these things. So it's basically just multiplying and dividing fractions. Bzz, multiply. Oh, I got to get a second one. Oh, I can't fight them. I can't do it. Okay, so we're going to try to multiply and divide these things. So you got to remember how to multiply and divide fractions. That's the first thing we're going to review. Okay, so multiplying fractions, remember you just multiply straight across, then reduce, or you could cross cancel, which is the simplifying part first, and then multiply across. That's what I'd prefer, just because it's a little bit quicker. So for this first one, we've got b cubed over xy times 2x squared y over 4ab. So we can cross cancel 1b, that becomes a 2. Cross cancel 1x and 1y. Cancel the 2 and the 4, and we've got bx over 2a. Perfect. The second one, okay, we're doing the same type of thing, right? But what's harder here is we're working with rational expressions, okay? So to do this, the best way to do it is to actually factor first and then multiply across. So let's factor the tops and the bottoms of everything that's here. So this could be factored, this could be factored, this can be factored. This one is already factored, so we don't need to worry about it. So we're going to rewrite this as we're going to pull out an a squared, left with a minus 6, over a plus 3, a minus 1. And we're going to multiply that by a minus 1 squared over a cubed. Now, we can just cross-cancel. Now that we've factored everything, now you can cross-cancel, okay? Back over here, you couldn't cancel the a cubed with the a cubed because you're adding and subtracting that a cubed. Does that make sense? You couldn't do the a squared and the a squared because you're adding and subtracting. Now that everything's multiplied, right, now we can. So, cancel 2 a's, cancel 1, a minus 1, and we're going to be left with a minus 6 times a minus 1. That's an a minus 1 right there, a little cramped, over a plus 3 times a. Okay, so a minus 6 times a plus 1, or a minus 1 on top. Let me fix that. A minus 1. Okay, a minus 6 times a minus 1 on top, and a times a plus 3 on bottom. Now dividing fractions. Oops. Dividing fractions. So remember that in order to divide fractions, you copy dot flop, right, or multiply by the reciprocal, or whatever you think of it. All right, if you just take the second part and you flip it upside down, then it turns into an easy multiplication problem. It's just like what we did up top. So we can, once again, factor and then cross-cancel right away. So we're going to factor this first one. Actually, we can factor this, we can factor this, but it's going to go on bottom, and we can factor that, and that's going to go on top. All right, so we've got a 1 plus x, 1 minus x, right? That's a difference of 2 squares over 3x plus 4 times, right? And if you need to put those in parentheses to remember that it's a full factor, right? That's obviously could be helpful too. Now, when I look at this right here, I see something that I know that I can factor but looks kind of hard to factor. One thing I noticed is we got perfect square and perfect square, and I realized that the square root of this is 3x and the square root of that is 4. So I just see like there's a 3x or 3x plus 4 in here. I'm probably going to have 3x plus 4 in my factoring somewhere. Okay, it's usually a good guess that you're probably going to be able to cancel something out. So this actually does factor to 3x plus 4 squared, and the bottom one factors to x plus 2, x minus 1. Okay, now we can cancel out 1x plus 4, 3x plus 4, sorry, one of the 3x plus 4s. And we see we've got an x minus 1 and a 1 minus x. So if we factor a negative 1 out of one of these, so if I factor a negative 1 out of this one, just negative comes out, then that becomes an x minus 1, right? So then we can cancel them, right? Or you could factor a negative out of the bottom. Doesn't matter, you're going to get the same thing either way. Okay, so the answer when you multiply straight across is going to be negative 1 plus x, or x plus 1. Either way is fine. 3x plus 4 over x plus 2. And of course, you could expand that again if you needed to get your final answer. Number two. So this is just a fraction divided by a fraction, right? Or a fraction divided by a fraction. Oops. Fraction divided by a polynomial. Okay, so we could rewrite it, right? We could factor all these things first. So we've got the first here is y minus 2p, y plus, not plus, 3, minus 3p, yeah, over y plus 2p. And then we're going to multiply that by the reciprocal of this, right? So 1 over, that's the difference, 2 squares, so y plus 2p, y minus 2p. Good, so we could do some canceling right there. The y plus 2p's we can combine to just make y plus 2p squared, so we've got y minus 3p over y plus 2p squared. Perfect. And this last one, you have to multiply and divide straight across. Okay, so we just would look at these two first, and then we'll take the answer and divide it by rs over t. Okay, so we've got, cancel 2 of these out, cancel 1 of these out, and cancel both s's. So we're left with r squared t squared over 1 times the reciprocal, t over rs. One of these cancel. And we're left with t cubed r over s. Perfect. So some more examples back here. Just a quick review of how to do the multiplying and dividing with numbers. All right, the way you do this is you got to multiply and divide left to right. So we divide first, then we'll multiply it by the negative 4/7. So we've got 21 over 10 times 10 over 9. Can't cross cancel. We've got 7/3 times negative 4 over 7. We can cross cancel again, and we're going to be left with negative 4/3. Okay, number 2. Similar, but now I'm going to throw some variables in there, right? We know this 0 power changes this to just 1, so you don't even need that, right? You're going to divide by 1 at the end, so none of that's important. So we're just going to multiply. Okay, so we can cross cancel. The negatives go away. The 7 and the 14 cancel. The 5 and the 25. And 1y. And we're left with y squared, 2y squared over 5. Perfect. Now, number 3, we have to divide these first and then divide by the last one. Okay, so we've got bq squared over c times c squared over q. Do some canceling. And we've got bqc over 1. And we're going to multiply that by the reciprocal of that. So times bc over q. Those cancel. We've got b squared c squared. Bam. Perfect. So number 4, this is when we're going to start getting some polynomials back in there, so we can work with those. Now we need to start factoring whatever we can. So we look at this and we see what can we factor. Well, we can factor this one. Oops. Get my peach marker. Okay, so we can factor that, and we can factor that. Right, the rest of them you can't factor. So we've got x plus 1, x minus 1, over x plus 2. Okay, you can only do one operation at a time when you're dividing, basically. Okay, you're going to multiply by the reciprocal here, times x minus 2 over x plus 1. Right, so you could do that first, and then multiply by the last one, or you could just multiply it all together. Right, if you're just multiplying everything, you could do them all at the same time, but when you start dividing, that's when it gets trickier, and you should only do one operation at a time. Okay, so this x squared plus 4, or minus 4 changes to x plus 2, x minus 2. I don't know why my plus is so high there. Over x minus 1. So we cancel whatever we can. So x plus 2 goes away, x plus 1 goes away, x minus 1 goes away, and we're just left with x minus 2 squared. There's 2x minus 2's, right? 1, 2 of them. Perfect. And the last problem here, just a quick reminder of what negative exponents do. So we need to take the reciprocal of these and the reciprocal of that. Okay, and then we're going to multiply them together. At the same time, we can factor this, we could factor this, and we could factor that. 2x minus 1 you can't really factor, so we just got 2x minus 1 over 2x. It's going to be a plus 1 and x minus 1. Yes, that's correct. Times, pull an x out of the x squared minus x, and you're left with x minus 1. And the difference of two squares right there becomes 2x plus 1, 2x minus 1. Perfect, and we got all kinds of stuff here that we could try to cancel. So we've got the x minus 1's cancel, we got the 2x minus 1's cancel, and so we're left with just x on top, and on the bottom we've got 2 of the 2x squared, or 2x plus 1's. So it's 2x plus 1 squared. That's all.